Alright, so we are back on the CR-10. I'm going to do the leveling. The bed has been zeroed out, so it's all the way down. I'm going to go ahead and turn the machine off, just so it doesn't move. So it's where we want it to be. I prepared my glass plate. I cleaned it up so it's nice and neat. And now I'm going to put blue tape on it. I like to use blue tape when I'm doing PLA, and I hear it's good for PET G too. So I'm going to go ahead and put blue tape on here. So this way when I do my leveling, it's to the actual surface. If you go ahead and level to your glass plate without the tape on, then there'll be a slight discrepancy, and that could cause issues with sticking, and you'll probably end up having to re-level it anyways. But those of you that you know, and for those of you especially who don't know, level, 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 level. Your gap on your leveling is absolutely critical to everything you do. If that is right, you're going to enjoy 3D printing. You'll probably have some success with it. If it's not leveled, then you'll just be wasting a lot of time. So anytime I have an issue, I'll always look at that. And one of the things I'm going to do with this, I'm going to do the visual level, which we'll do with the paper spacing, which is pretty standard. And then one of the first things that I run is I actually create, for all my machines, I have a leveling program, which is just a file that does a big rectangular square that goes around the entire maximum build area and then crisscrosses across the middle. And that's what I do with all my machines to get them zeroed in just right. So the first thing I do when I run that, the goal is to see and make sure obviously that the first layer sticks nice and well and you got a nice squish for the first layer. And then as it builds up, I design them typically to be about 2 millimeters thick by 2 millimeters wide all the way around and across the middle. And then I can put a caliper on it and see how accurate the machine is, what kind of shrinkage I'm getting. But it's a really good way to make sure that everything is dialed in right, that it's consistent, and once you've used the machine a lot, you'll know what to expect out of it. So if you're using something like that, a standardized leveling print square, I think it really, really helps and gives you an idea of where your machine is zeroed in at. So I'm going to go ahead and tape this up, and then I will go into the next step. Alright, so as you can see here, I've taken my glass plate and I've put a layer of blue tape on it. You want to make sure it's smooth, it's clean, it sticks well. And then it attaches to the plate. It just uses these little binder clips. And what you want to do too is you want to take out the tabs off of these so they're not sitting over your build plate area, just to minimize any sort of potential interference. I haven't printed with this. This is the first time I've done anything with this, so you guys are actually walking through this whole thing with me. We're doing it together. Yay! So the next thing I'm going to do is I'm going to do the level. And so what we want to do for the standard leveling is we're going to go and we're going to move the extruder around the plate and basically go from all four corners and adjusting these adjustment screws on the bottom so that the gap between the nozzle tip and the surface is about the thickness of a standard piece of paper. So this piece of paper, I'm going to end up sliding it between the nozzle tip and the surface, and I want it to not be so tight that it gets stuck. I want to feel a little resistance as I move the paper through. So I'm going to move the camera angle down so that you guys can see up close what I'm doing. Okay, so we're going to start the leveling, and one of the first things we're going to do is there's actually quite a big gap on all four corners of these. So this has an adjustment screws on four corners on the bottom. They're spring loaded, so if you turn them counterclockwise, is that right? Yes. Lefty loosely, righty tighty right. We're going to get it pretty close to the nozzle. So you can see this one closest to you I'm moving in. I'm going to loosen this side over here and get this bad boy much closer. And normally yours will be much, much closer, but the way this was given to us was the screws were locked in there. So I'm gonna put that there. I'm gonna reach around. I'm just gonna loosen this up. So it's much closer. These were really cranked down hard. So I'm hoping they weren't cranked down too hard to damage the springs. Excuse me. That was weird. Okay, let's see how close that one is. So this became much closer. Let's move this over here. So as long as there's no power to the steppers, or if the thing is on and you disengage the steppers, you can just move the unit around. So I'm going to start over here and I'm going to see if I can get it dialed in. So I'm going to take my piece of paper and I want to feel it. As I loosen it and I close the gap, this paper will get squeezed in between the plate and the nozzle. So I'm going to wiggle it around until I feel there's a little bit of drag. And because this whole plate is way off, I'm going to get all four corners in close first before I do any really fine-tuned adjustment. So that was dragging a little bit there. If you listen to it right now, you can feel it. It's just sliding right now, but once I get it to drag a little bit, this one is so far off that the other side of the bed is affecting it. So I don't know if you guys can hear the difference. There's a little bit of drag right there. So I'm going to slide this over this side. See if I can, there, now it's dragging. It's dragging a little too much because I can't pull the paper out. And I just want to feel it just like that. Okay. Go back and check this corner. See if this thing will still slide underneath. Yes, it does. I'm sliding my paper around. There, it's dragging too much. And you just want to do this on all four corners until you can get some resistance on the paper, that you feel that it's squeezing it a little bit, but you don't want it to get stuck. Okay, so there you go. Gonna bring it over here. We're gonna have to, oh, there you go. This is right there. So that feels nice. Just gonna double check the other three corners again, because this was so far off. There you go, that's good. Let's double check it again. Now once you've got it pretty close to level, any other times you're going to be leveling your machine, you're not going to have to, it'll be much closer than this. As I mentioned before, this thing was cranked all the way down on the springs, and so there was, I don't know if you guys remember, but if you look back on the video, there was a huge gap between the nozzle and the plate. So there you go. All right, that felt good. I think we're pretty close. That's got a good feel to it. Got a good feel to it. There you go. So we're leveled in according to what I can see. I'm going to go ahead and power it up one more time and zero the axes again and just double check it to make sure in case I shifted it at all. I just want to make absolutely sure, especially this being the first time I'm ever leveling this machine, first time working with this machine, so I'm not super comfortable with it. yet, but it's just like anything you do. The more you work with something, the more you do things with it, the better it'll be. Ooh, that is so close to this clip right here. Interesting. I'm gonna have to look into that. So you can see I just tried to pull on it. The stepper motors are all engaged, so I can't move it manually unless I either turn the power off or Creality has it set up. If I rotate my control and I go to prepare, disable steppers, now even with the power on, if that engaged, I should be able to move this. So I'm gonna just check this real quick. Check my level. I don't like that gap, see? It's a good thing I did that, so. Yeah, that gap was not the same anymore. I had to adjust that one. Let's see, how's this one? Yep, I can't even get the paper underneath it. There we go. Feel the drag there. Let's check this side. Your zero is the most important thing. So if you spend a little extra time on your zero, your gap right here is going to save you so much time and so many headaches. All right, so we've set up a test square in our Cura software, and I've loaded onto SD card. Now I'm going to go through the actual running of the first test print right now. And so the first thing I'm going to do is the machine's all set up, as you see earlier in the video, and I'm going to stick in our micro SD card into the slot in the side over here, and then I'm going to turn the machine on. So the machine's on. You can see it's telling us that we are what our adjustments are, temperature of the extruder, temperature of the bed, fan speed, things like that. And so in order to use this, you can press in to make selections and then rotate it. So prepare is to disable the steppers. We talked about that in a previous video. This is also where you do your homing. And just for fun, we're going to go ahead and do that now, just so you guys can see how that goes. I pressed rotate and selected home. And now the machine's going home just like we did in the normal leveling program. So this bed is leveled, and we're about to go through with printing our test squares. So once this has been leveled, I'm going to go back to the menu here, and then we'll press go on the test square, and you'll see one of the prints. We're going to do two test squares. We're going to do a large full-size one, and we're also going to do a smaller one, just so I can compare to the smaller printers that I have and see how close this printer is as far as results with PLA. All right, so that's home. Now we're going to take a look over here. I'm going to rotate you guys over, and now we're going to actually select it. I'm going to go ahead and press enter. Press it in to select. I'm going to print from SD, and then this will list everything that you've got in here that you want to print, the files that are on here. You do have the option to print directly from your computer via USB. I don't like to do that ever. The main problem with that is if you're plugged into your computer, if your computer goes to sleep, or are there any other issues with your laptop or whatever you have plugged into, then your print will just stop. So printing with an SD is the safest way to do it. And if you're really, really worried about losing power and some sort of issue, then put a battery backup on your 3D printer. And even if the power goes out, it'll keep running until the battery runs out. So we're going to go again. I'm going to go in, go to print from SD, and I'm going to select my test square G code. And then that will cause as you can see, the machine will warm up. So it's going to go up to temperature as far as I've got the extruder set to 210. The bed I've got set to not heating at all for PLA, so it's just going to stay at whatever it currently is, and it will not rise. But you can see that the temperature is slowly going up here for the extruder. Once the extruder is warmed up, this will start printing. All right, and I'm going to move you guys over so you can see the print start. All right, so we're going through, and what we're looking for is to make sure that the initial layer is good. And from there, we're just going to let our test squares print. As I mentioned before, this is a great way to kind of get a basis for how well your bed level is, and we'll be able to check it, as you'll see later, by actually taking measurements of these test squares and comparing them to others. All right, our test square, small test square, has finished printing. We're printing a big test square also. Let's pull this off and just see how well it stuck. One of the things we look for when we're doing a test square is adhesion, obviously. And after we pull it off, we're also going to be looking at how the thickness is and things like that. That'll all give us indications, and I'll talk about that more as far as, you know, what type of adjustments and things we might need to make. So for example, if one side initially when we were printing was starting to peel off, or there's some adhesion issues on certain areas, then that might give us an indication that we need to either raise the bed a little more to make it a little bit tighter clearance, or we need to lower it down because it's squishing too much. This print actually doesn't look very bad, and as you can see, I'm trying to move it right now. It is well stuck to the bed. One of the things that I do like about using this tape is not only does it protect the bed, not only does it help it stick, but you can also use it a ton of times. So if the tape doesn't get ripped up or ruined, you can keep using it. Otherwise, if a certain area gets messed up, you can just change that section of tape. So here we go. So usually what I like to do is just find a corner, and if I can use the nippers, the snippers, to get under it. You can see these are angled. These actually came with this machine, but I also, just buy whatever. It doesn't matter, cheap ones. They're great for cutting the filament and trimming, but they're also great, like I said, is like if you can just get one corner to pop up, then you should be able to just get your part to come right off, just like that. The bottom looks really smooth. There is a little stringing, but that's very common with these types of extruders. But overall, it doesn't look bad. What we're going to do next is I will get my big sample and this sample, and we'll actually look and measure them with a caliper and see how close they are to being. It should be 2 millimeter by 2 millimeter by 2 millimeter, each one of these sides. So we'll take a look at that in a second. All right, we've made our test prints on our awesome CR-10. We have 3 that we're going to look at really quickly. These 2 were both done on the CR-10, and I have another example over here which looks very close to the smaller one that's done on our little monoprice printers, which are very steady. So I just want to do a little comparison. We'll do some quick measurements on these and take a look at them. First thing I want to do is look at the smaller one. These are about 110 millimeters by 110 millimeters. They're both the same file. I set them up with the same layer thickness and everything so we can have a good comparison between the 2 printers. Dimensionally, they're the same. Finish wise, they're about the same. They're both kind of stringy, but that can be tuned in. That also is just I took a random design. These aren't really optimized, but the main thing we want to look at is on all 3 of these, how consistent these 2 by 2 millimeter sides are. And so we're going to use just a cheapy caliper, not that big deal. My fancy schmancy one is somewhere, but this one works fine. So what I look at on these, and I'm going to start with the CR-10s, is basically you've got all 4 corners, and I'm going to look at the big one. And what I want to see is that the thickness, number 1, on each corner is approximately the same. And so these should be about 2 millimeters-ish. They usually end up 1.9 with shrinkage. So that one's about 2. And you can see here where it peeled up a little bit, which is not uncommon on something super big, but let's just kind of go around the sides and we'll see. That's 2 millimeters. That's 1.8. Let's measure these sides a little bit. Oh, shoot. It's out of the camera range. 1.9. It's 1.8 over here. 1.8. 1.9-ish. That doesn't... Oh, there, I'm in the wrong spot. 1.9. 1.9. So it's pretty consistent all the way around so far. 1.8. 1.9. So basically what I'm seeing on this square is that it was 1.9 up here, 1.8 on this side around here, and 1.9. So that indicates that possibly this side is a little bit more squished. And so I can actually lower the bed a little bit over here possibly. And let's look at the smaller one. So this one is printed right in the center of the bed. So this is going to give us an indication of like the center of the area. One of the things that with glass beds, it's not so much of an issue, but if it's just raw aluminum beds, sometimes when people take parts off and on, they won't take care of it and they'll kind of bend it up. So this being a used machine, we don't know what it's going to be like. So far I'm seeing 1.9, 1.9, 1.8 a little bit over here. This is like the top left area of the print. So I'm saying 1.9. See down here at the bottom, this would be 1.9. So this is, it's pretty consistent all the way around in the center. And on the outside, maybe the bed's a little bit uneven. If I'm looking for super, super tight tolerance, then I might do something about it. But right now, I just want consistent prints that are going to stick. And this looks okay to me. Just as a comparison, this is done, this particular sample was done on our monoprice printers. And let's see what this one looks like. 2. Let's see. 2. 1.9. 1.8. 1.9. 1.9. And 1.9. Yeah, so pretty consistent as well. So this is, showing to me, it's set at 2. With the way the plastic shrinks and everything, it's not going to come out exact. So this is also a good baseline to get an idea of what expected shrinkage is. Like for this particular PLA, that's very consistent. So if I want it to be dead on, I might adjust my design file or my scaling to compensate for any shift in that. The other thing I'm just going to do real quick just to see is what's the overall width of this? Is my caliper wide enough? It is. So let's see. This is about 110.3, and this isn't the most accurate caliper, especially at the longer distances, but let's just see what it says. 110.2. Wow. Yeah, so pretty consistent, at least based on comparing to the printers that we use and we know are really reliable here. So that's pretty good. I'll go over and just show you the files in Cura in a second. All right, so we're taking a look at our Cura setup. Each of these, so that they were comparable, were set up with a 0.2 millimeter layer height. So not super fine, just to get them quick. Shell thickness of 0.4, bottom fill 1 millimeter, fill density 20. The speed really based on your machine. So our smaller machines can go a little bit faster, but we did this based on typical recommendations for the CR-10. And of course, over time you can adjust that and see, what materials you can run faster or not. The next thing is printing temperature for the head. So that's totally dependent on your material. And so we'll be putting out videos comparing the different materials that we've used. And even though it's PLA, depending on the color, depending on the vendor, your settings, the ability for it to stick, all those kind of characteristics really kind of vary. So being able to run something like this test square that's consistent so you can compare and really have a good baseline to compare your settings and to make your own determination on whether your settings are good enough or the material's performing the way you want. at least I found it is very, very helpful. And then of course there's no support on this at all. Like a lot of people, because this is a single head FDM, there's no water soluble, support material or anything like that. And particularly with, PLA and things like that, sometimes the support is detrimental to the actual part, and you tend to get broken parts and lots of issues that way. So, if I can, I try to get away with no supports. And something like this obviously requires none. So again, this is Cura. It's an older version. It's not the most current version, but it works really well for the machines that we run. I've got it set up for both the CR-10 and the monoprice. So I can just switch over here, and you can also see like the bed size changes when I switch to the monoprice, and you can see, just to give you a comparison, how big the small square is on the CR-10. And then again, just like I showed you in the physical one, I'm just going to load my large test square, just so you can get a view of how these bad boys are looking. So yeah, so that's that, and we'll go over parameters and other things in a few other videos.